Here's the case with your database. You are not the only tenant. You are not the only user. There are multiple people who are simultaneously inserting, updating, and deleting data from this database. Maybe those people are you in one script you wrote over here and you in one script you wrote over here, or maybe those people are you in an analytical script and some system that you wrote to populate this data via a data pipeline. Whatever the case may be, it's a very high likelihood that the reason why you're using a full database product like Postgres is because you have multiple simultaneous insert, updates, deletes, and selects. And if somebody is changing the data while somebody's looking at the data, how do we make sure that the person who's looking at the data gets a consistent view? You may have heard people refer to the properties of a database in terms of things like acidity, that database transactions, you should be able to group queries together and you should be able to do those transactions in their entirety or not. And this is often referred to things like inserts and updates. If you plan to do insert, but this one fails, you should be able to roll all of them back so you don't have some partial state. Consistency, that for example, if you do inserts, constraints, and things like that, you're following those constraints, that you're making sure that you don't insert data that's incorrect. Isolation, for example, if somebody's inserting something and then doing a select here and then inserting something else and somebody's doing the same process here, these don't interact or interfere with each other because there'd be no way to reason about that. And durability, once something has taken effect, it's taken effect. It's not the case that your transaction, your collection of queries comes back and says, I'm done, but then some power loss or something else, causes that to not be committed. And these four characteristics are fairly hard to actually engineer to ensure occur on a database or database product. When we talk about isolation, however, we're often talking about something that's a little bit closer to our use case. Namely, if I have multiple analytical users or analytical users who are working at the exact same time as when the data is being collected, how do I make sure that the analytical users are seeing something meaningful? And isolation is about being able to write a query or a collection of queries, and those queries being something you can reason about without knowing everything else that's happening at the same time to the data store. If this data store is immutable and nobody's doing inserts or updates or deletes at the same time, or nobody's doing inserts, updates, deletes at all, the data store is just done, everything's been collected, none of this really matters because everybody's going to always see the same data. Every select is going to give you the same results because the data is not going to change. But if the data is changing, then you want to avoid things like dirty reads. You want to avoid reading data that hasn't yet been committed. Reading data that's not there or not guaranteed to be there. For example, a transaction occurs, some data is partially written, but the transaction isn't able to proceed and be committed, but somebody else sees something. Non-repeatable reads you want to avoid, where a row is retrieved twice, but the values of the row differ. You look at it, and then some change happens and you see something different. Phantom reads. You have rows that are added or removed as records are being read, and that can be very confusing because you might do a select up here and then a select down here, or you might do a sequence of select operations in a sequence of common table expressions, and it can be very problematic if you're doing a join, but things are leaving existence or popping into existence. And then serialization anomaly, which is the idea that if you have multiple transactions that are running at the same time, you can reason about them as though they were not running at the same time. In general, your database will provide you with isolation levels. It'll provide you with the ability to specify how isolated is a transaction. And for the highest isolation level, the serializability, you typically have some constraints, namely that these things have to be repeatable, that these things have to be serializable, that there might be some blocking. There are some consequences of just, it's too strict. It's too strict to run at the serializable isolation level. In general, databases like Postgres will run at, say, read committed, which is an isolation level where a select will only see data that was committed before the query began, but within a transaction, it can see the changes that its own transaction has created, even if those are uncommitted. So a select can see non-repeatable reads, or rather, within a transaction that's read committed, you can have non-repeatable reads where you do a select, then you do an insert, then you do another select, or you do a select, you do an update, and you see a select, and these two selects see something different. You can see your own changes, but you can't see other people's changes. That's read committed. But if you're doing something while somebody else is doing something, well, you're not going to see their results unless they completed what they were doing prior to you starting. And so that's the general isolation level that you have to work with. There are other isolation levels, like repeatable read, where you can say, you know what, make sure that I can only ever see data prior to this transaction, and I never see any uncommitted data or any changes during that transaction. And it may be very important that you have multiple select statements and you see exactly the same result. Because think about this. You don't have variables in SQL. And as a consequence, oftentimes one of the ways that you pipe information from one part of an SQL statement to another part of an SQL statement is by just rerunning it in a common table expression or a subquery. If it's the case that you are looking at some result and you anticipate that it shouldn't change, but because you don't have a variable, you can't just store this result somewhere, you need to just rerun that query in a subquery or a CT or some other mechanism. What are you going to do? Well, a temporary table is one option that you could use, where you could say, give me the state as I see it now, and then keep referring to that, and you wouldn't be able to see changes during the transaction. You'd be able to isolate those. But if that's not the choice that you have, you might want to use something like a repeatable read isolation level or a higher isolation level as your use case requires. Whatever the case may be, it is important if you are writing transactions that do both selects and other changes, or if you are doing selects while the database is changing, that you understand how much of that you can see. And in this very brief introduction to isolation levels, I want to introduce you to at least the core concepts and the core vocabulary around understanding what could change and what these isolation levels are able to lock down and to allow you to assume might not change during a transaction.